So welcome to our channel. So in this lecture I'll solve the most repeated problem on equivalent resistance when referred to primary and when referred to secondary. So a 40 kVA transformer with the ratio of 2000 volts divided by 250 volts. This is called the primary induced EMF and this one is secondary induced EMF. Has a primary resistance of 1.15 ohms. See, R1 is equal to 1.15 ohms and the secondary resistance is R2 is equal to 0.0155 ohms. Suppose in the problem he may confuse if he gives 250 by 2000 volts. How can you choose the primary induced EMF as a 250 or 2000? See the winding resistance. If the winding resistance is more, that means the induced EMF in the primary winding is more. If the winding resistance is less, the induced EMF in the resistance side, that will be low. R1 is equal to 1.15. So that's why it is called as a E1 is at high voltage, E2 is at low voltage. E1 is the primary winding induced EMF and this one is secondary winding induced EMF. Now you can write it as E1 is equal to 2000 volts, E2 is equal to 250 volts. And what is the formula? Total resistance when referred to primary R01 is equal to R1 plus R2 dash R1 plus R2 by K square. What is K? K is equal to E2 divided by E1. So that is 250 divided by 2000. So 250 divided by 2000 is equal to 0.125. The R1 value is 1.15 plus R2 value is 0.0155 divided by K square 0.125 whole square. Now what is the answer? Total resistance when referred to primary, that should be equal to 2.142 ohms. The total resistance when referred to secondary R02 is equal to R2 plus R1 dash, it is R2 plus K square times of R1. 1.15 is R1 volts into K square. K square is 0.125. So 0.125 whole square plus what is R2? R2 is equal to 0.0155. Students, don't confuse here. So this is K square R1. K square R1 plus this one is R2. Okay, 0.0155 plus 1.15 into 0.125 whole square, then I will get it as 0.03346 ohms. And after that he is asking the total resistance drop on full load. For that I2 into R02, that is the second bit. How can I calculate I2 value? See, in the given data is given as 40 kVA. So S is equal to 40 kVA. I2 is equal to kVA divided by E2. That means secondary induced EMF. Then I will get the current. Volt ampere divided by voltage. Then I get the ampere. That is called the current. So 40 into 10 to the power of 3 divided by secondary induced EMF is 250. 250 value 40 into 10 to the power of 3. I am calculating in Calc divided by 250 is equal to 160 amperes, but he is asking I2 or R02, so that is the drop in secondary side resistance. The total secondary side resistance means total resistance when referred to R02. So 160 into R02 into 0.03346, that is 5.03346 is equal to 5.3536 volts. This is the drop in the total resistance drop on full load. Total resistance drop on full load when referred to secondary side. Suppose if you substitute I1 into R01 also, you will get the same answer, that is 5.35. The total copper loss, what is the total copper loss formula? You can use I1 square R01 or I2 square R02. So total copper loss on full load is equal to I2 is 160 whole square into the R02 value. What is the R02 value? 0.03346. So finally I got it as 856.576 volts. So this is the most important problem, and this is a previous year problem in one of the university. Like, share and subscribe to my channel. Thank you.